Substitution reaction of square planar complexes. Substitution reaction of square planar complexes that should be occur by this pathway. Okay, this pathway. We normally know substitution reaction means this is the replacement of one group by the other. If we termed as organic chemistry, we know aromatic electrophilic substitution reaction, nucleophilic substitution reaction, SN1, SN2, SNI. Okay. Normally we know what that is SN1 type of reaction means. That is carbon having 2 or 3 CH3 group or C2H5 group, that is tertiary carbon is more favorable for SN1 reaction, and there should be one good leaving group, and good leaving group that should be leave the carbocation. One good leaving group that should be leave the carbon atom, then carbocation is produced as an intermediate, and then solvent or nucleophile that should be attached to the carbocation. Okay, this is termed as SN1 reaction. SN2 reaction, there should be nucleophile attack on back side of the carbon atom and leaving group leave the carbon, and by this way product formation can be take place. So in SN1 we get receiving mixture normally, that is plus minus mixture, and by SN2 we get overall inversion. Okay, and for SNI we get ultimately retention. Okay, when NGP can be there, that is neighboring group participation, we get square of inversion, ultimately we get retention, that is 2 inversion can be take place. So by this 2 inversion we get ultimately retention. Okay, but there should be difference between the substitution reaction in terms of organic and inorganic chemistry. In organic chemistry we consider carbocation as intermediate or transition state as a species, and we consider their stability. But when we consider inorganic chemistry, there should be some geometrical changes can be there. Okay, so when we consider octahedral and square planar complexes, there should be some difference. That is, octahedral complexes having cohesion number 6, and there must be metal having so many ligands, though their space are not so much there. So due to this associative pathway, that is any ligand approach from the back side and leaving group leave, that is like for SN2 reaction type reaction, are not permissible. But when we consider square planar complexes, there should be upper and lower side that should be vacant. Okay, so enough space that should be there, so it easy to attack nucleophile or solvent from top or bottom side to the square planar. Okay, now we consider all of the things. Now square planar complexes means what? That is having cohesion number equal to 4. Okay, so when we consider cohesion number 4, we get 2 different geometry. One is tetrahedral, other is square planar. Okay, tetrahedral basically sp3 hybridized, as for example methane. In similar geometry but having lone pair, we consider ammonia also, water also, but due to lone pair their shape is not same. Or water is V shaped or bend shaped, we can say. Okay, but square planar basically DSP2 and sp2d type hybridization. Okay, so that should be having this type of orientation. Okay, that is these square planar, these things are the planar. Okay, all the atoms are in plane. You can say that is there should be one Cl and one ammonia present as above the edge. Okay, and Cl and NaC is below the edge. But actually this above the edge means this is front of our eyes, and the below the edge means this NH3 and Cl are back of the, that is far from our eyes. Okay, but actually they placed in same plane. Okay, now substitution can be occur easily for square planar complexes, as their upper and lower side that should be vacant. Okay, observation consistent with a trigonal bipyramidal transition state in which cis ligands are axial and TXY are equatorial. Okay, first consider there should be, this is an initial complex. Okay, CC means same group that should be present in transposition. The 2C are the same group that should be present in the transposition. We have to place all of the configuration as both of the C will be trans. Okay, there should be lots of geometrical changes, but there should be one thing will be fixed, that CC will be trans. Okay, when incoming group attack on the above or below the side, we get this type of configuration. This is called trigonal bipyramidal structure, TBP shape. Okay, so we get 2CC, so orientation will be trans, and other, that is leaving group, incoming group, and the spectator ligand will be in the same plane. Okay, leaving group, incoming group, and spectator ligand, that should be T, are in the same plane. Okay, then again Y, X that should be the leaving group and X that should be removed, so we get overall this product. Okay, but this way also described by solvent path. So solvent path means first solvent molecule that should be attacked, and they produce some intermediate state. After that, nucleophile attached with it. First solvent react and solvent produce some product, and then after that nucleophile attack. Okay, this is called solvent pathway. In solvent pathway, there should be solvent place this incoming nucleophile site. Okay, then solvent go and nucleophile that should be attached with it in the same intermediate species. Okay, same intermediate state, there should be first solvent attached, then after that nucleophile attached, and then we get product. Definition of substitution reaction means ligands are generally electron rich species. They always show tendency to donate its lone pair or donate its negative charges. Okay, so they have been ability to donate electron pairs if they have been lone pair, and sometimes they give their electron density to the metal. Okay, hence they act as Lewis base or nucleophile. So ligands are generally electron rich species, and they have been ability to donate electron pairs, and hence they act as Lewis base or nucleophile. Lewis base means Lewis bases, the bases who are always show tendency to donate is lone pair or electron density to the positive metal or positive any side. Okay, and nucleophile that should be always we can term as nucleus loving group, who always love positive side. Okay, the chemical reaction of a complex compound in which its one or more ligand is replaced by another ligand is called a ligand substitution reaction. When ligands are replaced by another ligand, that should be termed as ligand substitution reaction. Since the ligand is nucleophilic in nature, always nucleus loving group, that's why the ligand substitution is termed as nucleophilic substitution reaction, or we better can say SN reaction. Okay, suppose there should be MXN. X is the ligand which are still there, that is MXN, and plus Y. Y is the incoming group, so we get MXN minus 1 Y plus X, because one X remove and other Y that should be attached with it, the metal. One X removed from the metal and one Y that should be attached to the metal, so we get MXN minus 1 in Y plus X. Okay, classification that should be unimolecular nucleophilic substitution, or we better can say SN1 reaction. Unimolecular, that should be only depends upon one, that is one species concentration. Okay, that's why we termed as unimolecular nucleophilic substitution or SN1 mechanism. Other is bimolecular nucleophilic substitution reaction. SN2 reaction means that is depends upon the two species concentration. Now, mechanism of ligand exchange reaction octahedral complexes. There should be MnX. X is the leaving group and L is the spectral ligand. Spectral ligand means who are not changed during the reaction or after the product formation. Who is still before the reaction and who is still between the during the all over the reaction and also still unchanged after the product formation, who do not play any types of direct role. Okay, and X is the leaving group and Y is the incoming group. So we get overall MlNY plus X. X is replaced by Y simply. Okay, there should be two types of SN reaction. That should be, one is dissociated. Dissociatives are termed as unimolecular nucleophilic substitution reaction. Okay, it should be concerned about the initial complex concentration. Okay, and as it is only depends upon the leaving tendency of the leaving group, so does not depend so much on the concentration of incoming group. Okay, but associative is always bimolecular nucleophilic substitution reaction because there should be approaching ligand should be considered. Okay, their concentration that should be considered. Now MlNX, that is X is removed, so we get MlN. Y added, we get MlNY. Okay, as their MlN intermediate is produced, so there should be, we know this intermediate produced due to leaving of X and does not depend on the incoming nucleophile their concentration. So we can better say unimolecular nucleophilic substitution reaction. Okay, associative, they are first Y used and then Y produced with MlNX, that is whole over the initial complex react with Y and produce intermediate MlNXY and then X remove. So overall reaction depends on both of initial complex concentration and nucleophile concentration. So we can say bimolecular nucleophilic substitution reaction. Okay, so for unimolecular nucleophilic substitution reaction always depends upon most of the cases by the leaving tendency of X. Okay, and there should be intermediate produced and this intermediate will be having lower position number than the initial complex. And bimolecular nucleophilic substitution reaction or associative mechanism, there should be first nucleophile that should be attached and produce higher cohesion number intermediate than the initial complex and then leaving group dissociate and produce product. Okay, so that should be obviously depend upon the concentration of Y. Okay, now there should be interchange mechanism. Interchange mechanism means there should be bond breaking and bond making can be taken place almost same time or simultaneously. Okay, but there should be two types of interchange mechanism. One is IA, associative interchange, ID, that is dissociative interchange. IA, if association is more important, ID, there should be dissociation is more important. Okay, interchange may be dissociative or may be associative also, depend upon which step is more important. Okay, now unimolecular nucleophilic substitution reaction rate only depends upon K and concentration of MXN, that is the initial complex. First MXN, there should be slow process. As we know, bond breaking process always needs some amount of energy. This is always endothermic process. When you break some bond, we have to provide some amount of energy. So this respect to this case, this process is lower process. Okay, so as it is lower process, this is the rate determining step. So we get intermediate complex MXN minus 1, that is lower cohesion number than the initial complex, and plus X. Okay, so MXN, there should be X leave, so we get MXN minus 1 intermediate complex, and by this way cohesion number decreases, and for baking process we have to provide some amount of energy. So this process overall slow process, and this is the rate determining step. Okay, and now nucleophile attached with MXN minus 1 And then this is the first step, because always remember association of bond and dissociation of bond. When bond breaking process is there, this is definitely need some amount of energy. Otherwise bond break is not easy. You have to provide some energy. But when we always associative pathway, there we sometimes we do not need also to give energy, or if we have to do some energy, but little of energy can be sufficient. Okay, so this is first reaction. Okay. Bimolecular nucleophilic substitution reaction, that should be rate equal to K equal to mxn into y. Mxn must be initial complex and y is the nucleophile. There should be slow process, activated intermediate complex. There should be activated intermediate complex, that is mxny, and we get mxny, then x is dissociated, and again we get mxn minus 1 y and plus 6. Okay. Most of the cases octahedral pathway we perform dissociative mechanism because of two reasons. One is they are having 80 electron configuration, so this is stable configuration. When two ligand approach, their overall configuration will be 20 electron configuration. This is not favorable. Okay, this is the first reason. And second reason, due to coefficient number 6, octahedral complexes are having less space. Okay, less space for incoming nucleophile, and when incoming nucleophile come, there should be steric congestions will be there. So that's why associative mechanism is normally not favorable for octahedral complexes. So octahedral complexes, normally dissociative pathway is more favorable. Okay, but when sometimes dissociative pathway and migratory insertion is there, so always migratory insertion is more favorable than dissociative pathway, because dissociative pathway bond break is needed, so we have to give some amount of energy. But when bond migration will be there, so there we not need to give any type of energy. If we need, the less amount of energy can be sufficient. Okay, so if there must be any options are there, that is dissociative pathway and migratory insertion, so there should migratory insertion is more favorable. Okay. And this pathway, that is bimolecular nucleophilic substitution reaction, that should both depend on initial complex and nucleophile. This is basically favorable for square planar. Okay, because of two reasons. Square planar having 16 electron configuration, that is also stable, but when incoming group that should be attached with it, they got 80 electron configuration. Okay, that's why they are stable. Okay, another way, another way they having space, upper and lower having vacant space. So when nucleophile attached with it, there should be no steric congestion will be there. Okay, so mxny plus y, this is also slow step, mxny produce. This is also set determining step, and then mxny, that should firstly react to produce mxn minus 1 y plus x. Okay. So pathway also have reaction, that is platinum A3x plus y, it must be produced platinum A3y and x. For understanding, we taken all the ligands except incoming and leaving group are taken as A. Okay, so this is the square planar complex. When y incoming group attached from the top of the view, so we get this type of square pyramidal geometry. Okay, square pyramidal geometry. Then this square pyramidal geometry convert into TBP shape, where A are still are trans to each other, and 1A that should be cis to each other. Okay, then again square pyramidal. Okay, and last one x that should be removed, and we get the product. Okay, this is the pathway. First one, any square planar complex, there should be near nucleophile attached. So in that case, square pyramidal geometry can be produced, and this square pyramidal geometry convert into TBP shape, and then TBP shape again convert into square pyramidal, so we get ultimately square planar. Okay. Actually the square pyramidal complexes are short lived, so we cannot say always in the mechanism square pyramidal intermediate. We can shortly use that is TBP shape intermediate, then again get product. Okay. Now consider progress of reaction. The formation of MOI bond and breaking of MX bond. There should be reactant and there should be product. Product get more stability, so their energy that should be more low. Okay. This is the formation of MOI bond and breaking of MX bond, equally important. Both are equally important, so we get this type of gap. Okay. But when formation of MOI bond is the rate determining step, on that case this is the gap, MOI bond. MOI bond is the determining step, on that case we get this type of gap. And when dissociation of MX bond is the rate determining step, on that case we get this type of gap. Okay. There is 3 cases. First one, MOI bond and MX bond are equally important. So there this area energy difference is not so much. In that case MOI bond is the favorable process. On that case MOI bond need more energy. In that case MX bond dissociation is more important. So MX bond will be need more energy. Basically these all are depend on basically octahedral complexes. Okay. Now square planar complexes have following striking features. That should be first one, these are tetracoded cohesion number 4 and hence codably unsaturated. Unsaturated means they have extra place. And these have 2 vacant cohesion sites that should be above and below the square plane, so they can able to perform in associative mechanism. Okay. These have 60 electrons in the variation of the center metal ion, hence are electronically also unsaturated because 80 electrons is most favorable and most stable configuration, so they are electronically unsaturated. And these have vacant pz orbital that should be perpendicular to the square plane. You know that is p orbital having p having 3 orbitals, that is px, py, pz. All are perpendicular to each other. If we consider this is px, this should be py, this should be pz. They all are perpendicular to each other. As px and py, they are engaged to perform D2sp, DsP2, sp3d type hybridization. So that is pz orbital remains still there, and that should be vacant, and that should be perpendicular to the px py plane. Okay. So pz atomic orbital perpendicular to the square plane, which can accommodate the electron pair donated by the entering ligand. Okay. Square planar complexes as EN means APT atomic number value less than nearest noble gas. Okay. Because they having 2 electron less. Square planar complexes are octahedral complexes, that is nickel to D8 system, NiCN whole power 2 minus EAN APT atomic number that should be 34, and nickel NH3 whole 6 2 plus APT atomic number 38, so that is 4 is less. Okay, 4 less. APCN whole 6 3 minus APT atomic number 35, and APCl whole 4 2 minus Cl4 minus APT atomic number 31, 4 less. Okay. D7, that is cobalt Cl whole 4 2 minus, that is APT atomic number 33, and cobalt OH2 whole 6 2 plus APT atomic number 37, that is also 4 less. Okay. Square planar complexes are 60 electron system, that is platinum 2 palladium 2 D8 system. They are undergo most of the cases platinum 2 and palladium 2 always form square planar complexes. Okay. Platinum 4 that should be produce octahedral complexes, but platinum 2 always produce square planar complexes. When we go nickel to palladium, that is nickel to palladium to nickel to platinum, nickel to palladium to platinum 2, right? So nickel 2 can be produce octahedral complexes, tetrahedral complexes, and also square planar complexes. Palladium most of the cases produce square planar complexes, but platinum 2 always produce square planar complexes. Palladium Cl4 2 minus, platinum Cn4 2 minus, platinum Cl4 2 minus, platinum C2H4 whole Cl3 minus. The platinum to compensate at affinity atomic number 84. Okay, but nearest noble gas having configuration 86. So that should be 2 less. Okay. Iridium 1D8 system, that is must be iridium CO Cl PPSC whole twice, that is affinity atomic number 76 plus 4 into 2, ultimately 84. Nearest noble gas radon having 86. 4 that should be less. 2 that should be less. Okay. Similarly, platinum 0, platinum PPSC whole 3. That should be affinity atomic number 84. That should be less than 2. So that's why 60 electron configuration square planar complexes are electronically unsaturated. Okay, so they need extra electrons. Okay, to produce noble gas configuration, to produce effective atomic number of nearest noble gas. Okay, so they are coordinately unsaturated, electronically unsaturated. So that's why they need extra ligand to perform in square planar associative pathway. Okay. Next day I will explain other factors also. That is trans effect, that is solvent pathway, that is Nicophile pathway. Okay, up to this.